Hello, everybody. Um, Today we're going to be learning how to differentiate and integrate. Actually, I don't remember which. I don't think you've learned any calculus with trig. So we're going to learn differentiating and integrating with sine and cosine are what's it called? Trigonometric functions. So we've done differential and integral calculus with polynomial functions and with exponential and logarithmic functions. So what's left is our trigonometric functions. So I'm going to start you guys off with this exploration today. Excuse me. I'm going to explain like what you should be doing for each section. And then I'll post a full solution on the what's it called, on the Power School Learning page, and check yourself when you're done, okay, or if you get stuck, but try to see what you can explore on your own. Okay, so we're going to start with sine. It says the graph below shows the function f of x equals sine x on the interval from 0 to 2 pi. Analyze the graph determining the values or intervals where f of x has stationary points, is increasing, and is decreasing. Then fill out a sine chart. By sine there, this means like plus or minus. For f prime of x, and use your sine chart to sketch a graph of f prime of x. Okay, so it wants you to look at your graph here, and it wants you to notice, like, hey, there's a stationary point here, stationary point there, increasing, decreasing, increasing. And then here, so we have x values, right? We start at 0, we end at 2 pi, okay? We have pi in the middle. This means that pi over 2 must be right here, and 3 pi over 2 is going to be right there. Okay, so these are the little intervals that it wants you to look at. I knew that because the sine function is periodic, its period is split into like 4 even pieces. That's why I did this. You could have looked at this and said, okay, it starts at 0, it increases until this stationary point at pi over 2, then decreases through all the way till 3 pi over 2, and then stops at 2 pi. And then what you're going to do here is you're going to put a plus or a minus or a 0 sign in each of these boxes. Okay. And then according to that, you'll know where the 0 values are on this graph. Okay. So you can just like plot those points. And then you'll know that the graph has to increase until or decrease until it hits that 0. Actually, wait. Because it is positive, and okay, so I'm sorry, guys. Let's just do the first one together. So at 0, we have a positive, it is increasing, okay? At pi over 2, which is right here, halfway between 0 and pi, we should have a stationary point 0. So at pi over 2 on my derivative graph, I know that my actual y value has to be 0 right there, okay? Now this plus right here, for this part means increasing, but right here means positive, okay? So whatever is here has to be positive, okay? Yeah, so you know that you have like something here that's positive. Then you would move on. At pi, we are decreasing. So you know that it crosses here and it's going to have something going negative like that. Okay, so then you're going to try to fill in the rest of your graph according to your table and see what you would get. Okay, so I would first plot wherever you have stationary points, put those points on the axis, and then use your plus and minus increasing or decreasing. Increases is going to mean you have a value above the x-axis. A decreasing is going to mean you have values below the x-axis, okay? So then it says, what function does the graph f prime of x look like? You'll answer that. Hopefully you should be able to see, and you'll write out the rule, okay? I'm going to post the solution for all of this, so don't worry. Then using that rule, you're going to complete all of these examples, and you can check your answer in the solution, okay? Differentiating this, there is a typo on your sheet. It should say cosine. Okay, it's here, but I'm sorry, there was a typo. I've fixed it now. Okay, so again, you're going to look at your x values. It starts at 0, ends at 2 pi, so we're going to have like the same values here because sine and cosine have the same period. Okay. And then you'll look at this and you'll say, okay, the derivative at the very beginning is 0. That's my stationary point. And then it's decreasing until pi, so I should have a negative right there, okay? And then again, right here, so we know that the value 0 has to be right here. And then it's decreasing, which means it must go below the x-axis after this stationary point. Okay, then you're going to look and ask yourself, what does this look like? And that should give you the rule. And then you should be able to take the derivative of all of these functions. Okay, so that's differentiating sine and cosine. You guys will go through and do those explorations on your own. And then we move on to tangent. Okay, so let's see. Tangent can be done multiple ways. Let me see. So the easiest thing, since I didn't do a little exploration for figuring it out, although you could totally prove it, will be just to look in your formula booklet and go to the, I believe, the calculus section. And it should have, these are trig. It should have the derivative, yeah, there for you. Derivative. Oh, it doesn't give it. That's interesting. So, yeah, it gives you the derivatives of sine and cosine, but it doesn't give it to you for tangent. Interesting. Okay, so we could figure this out basically by remembering that tangent of theta is equal to sine of theta over cosine of theta. Okay, and so we can rewrite each of these functions as sine over cosine. So sine of x squared minus 4 over cosine of x squared minus 4. And then we can take the derivative using the quotient rule of each of those pieces. So that's what I would do. The derivative of tangent should end up being secant squared theta. So 1 over cosine squared theta. So you should get the same theta on the inside. And you'll have to use the chain rule since the theta isn't by itself here. And then there are some application problems at the bottom. Make sure you're able to do those. Check your solutions when you're done. Good luck. And then I'm going to give you some notes. All right. Thanks, guys.